Here's a video on how to write and graph a parametric equation for nonlinear motion using a TI-84. Base pitcher Bobby Bones throws a baseball with a velocity of 80 feet per second. The ball is released 4 feet above ground and 6 feet in front of the pitching rubber. The angle of release is 3 degrees. The horizontal component has a rate part to it. Since it's 80 feet per second, that is 80 times the number of seconds it's in the air, times the cosine of the angle that it's released at, which is 3 degrees, plus distance out in front of the rubber. Most of this comes from our previous work dealing with equations, dealing with parametric equations, or dealing with position on a coordinate plane, position vectors. The y component, the height, also has a rate of 80t times the sine of an angle of 3 degrees plus the distance it's released above ground, which is 4. Now, using what I said before about position vectors, this would be a pretty good graph or position vector that would be traveling at 80 feet per second. These are not correct, and I will point out why in just a little bit. So if we take a look at the graphs, here's 80t cosine 3 plus 6, 80t sine 3. We go to our window and presume that the baseball might be in the air for 2 seconds, starting 10 feet behind the rubber to 80 feet beyond the rubber, which would then include a 60-foot home plate, or the home plate being 60 feet away from the pitching mound, going by fives, y, going from a -5 up to, I don't know what the maximum height might be, 10 or 15 feet by ones. So our graph looks like a baseball that's being thrown, and it just keeps going and going and going. We know on Earth that's not exactly what's going to happen, because there's that pull of gravity. It's going to bring this back to the ground. I need to adjust my equations. I need that vertical component to have the pull of gravity be represented, which is minus 16t squared plus 4. If I go back to here and I type in 80t sine of 3 minus 16t squared plus 4, and I'll graph it, you'll see there's that curve being represented through the baseball. The question is that enough velocity to be considered a strike when home plate is 60 feet away? We'll trace your function and let's find out. So at time 0, the ball's being released 6 feet in front of the pitching rubber, 4 feet high, and max at the highest somewhere right around 3.5, 4 feet, or 4.25 feet, somewhere right there. And I can say, well, I get pretty close, there's 50, the pitching mound and home plate are about 60 feet apart. So it looks like it may actually come up a little bit short. But to find that, I'm going to go second calc. And I forgot, in parametric mode, it does not have that 0 function to calculate the 0 of a graph. So let's just go back to our graph. And we will zoom in a little bit closer. We can build a table. And so if we were to look at this a little more closely, you'll find that the height is 0 at 57.5 feet from home plate, or from the pitcher's mound, which means it's going to come up a little bit short. So the answer down here is 9. 57 and a half feet. We will examine more closely how to solve these types of parametric equations a little bit later.